What's going on, guys, and welcome to the first video of KnexFlex Designs. In this video, we are going to be covering the circuitry and programming or code of my product. So to begin with, the circuitry is fairly simple. As described in the previous video, all it is a microcontroller reading angles from a magnetic encoder and transmitting that to an SD card reader. So the first thing we start with is the Arduino Pro Mini microcontroller. All of these products can be all of these components can be found on Amazon. And yeah, all it is the Pro Mini microcontroller. There is not a lot to it. Obviously, all of the pins for power and output and ISP and whatnot. There's a reset button down on the bottom to reset your program and code. And yeah, so quite small, quite useful, quite powerful. So to go along with that, there's no port for a cord to plug in to program it. So what you have to get is an Arduino programmer. This one is from HiLetGo. It's called the FT232RL Mini USB to TTL serial converter adapter module, 3.3 volt or 5 volt. And yeah, it's not as complicated as it sounds. All it is it has a port for USB to plug into for a cord, and then you simply connect it to your microcontroller through these side pins down here. It'll simply connect like this, and then you're all set to go. When you have it plugged in to a cord that's connected to your computer for programming, you'll see a red light pop up right there. And then when you plug it into the microcontroller properly, and I dropped it. When you plug into the microcontroller properly, you'll see a light up on the microcontroller. You kind of have to mess with it. Make sure it's pressed all the way against the pins. I have it bent down to keep the light on so programs can be transferred over appropriately. But yeah, also something I've noticed is this product is the official Arduino microcontroller. I have a couple others that are from HiLetGo where you kind of have to plug it in the opposite way, and you can only plug it in one way, or you have to plug it in the opposite way. This one works both ways, as you see it lights up both ways, but for the HiLetGo ones, I have seen that you can only plug it in going like that. But I don't know, just kind of mess around with it. It's not too bad to figure out. So yeah, that's for programming. You just plug this into your computer, and then you can programming using the Arduino software, Arduino IDE. So yeah, so you have the microcontroller. The next, probably most important part, is the magnetic encoder itself. This one is a square, fairly small. It's called the AS5600 magnetic encoder, AS5600. Basically, yeah, it's fairly simple. The encoder itself is in that middle, the little black thing, and then it's got 7 pins. You got the VCC and the ground over there, and SCL and SDA on the other side. Those 2 pins are going to be very important, SCL and SDA, and VCC and ground. Those are the ones that you have to have connected up. The encoder also comes with a magnet, of course, for the other side. Basically, it's quite a small magnet. It's hard to hold, hard to see. It's like that. I'll connect it with these pair of pliers, so it's easier to see. But yeah, basically that's all it is. A little circular magnet like that. And all you want to do is line it up in a way when you set up your circuit or whatever, so that the magnet is about 2 millimeters away from this end, and one side spins either side while the other remains still, and the encoder will track the angle of the magnet that it has rotated. So yeah, fairly basic design concept. And I'll go more into how the joint itself works in a later video, and describe that, but it's fairly simple. So then two more components. We have the SD card reader itself. All it is a little port for the micro SD card. You put in the top and slide it in, and then it holds it, read your data, take it out if you need to. And yeah, it's quite basic process. And then you have all the pins at the bottom sticking out. The ground, ACC, MISO, MOSI, SCK, and CS. Those all need to be wired up. And yeah, if you guys want me to go into how exactly to wire all the components up or give a diagram of how everything's connected, let me know down in the comments and I will do that. And then the final piece is, I guess there's two more. So you have the battery controller, I guess. Basically, all this is used for is protecting the battery's output and protecting the battery input when you're charging it, basically. So this end just connects to a USB-C port, and then you have the pins down here. These up here don't need. You'll see if you look closely, there's an out plus pin right here. There's an out minus pin, and then a B minus, B plus. So for B minus, B plus, that is where you connect input. I'm sorry. That is where you connect. Oh, I'm sorry. Blanking. That's where you connect it to the battery itself. So this would be hooked up to the battery so that the battery's power runs through the circuit, and through the out pin, through the out minus pin, you connect the negative terminal of the microcontroller. Through the out plus pin, you connect the positive terminal of the ACC or the VCC of the microcontroller. So yeah, and then of course you have the battery itself. A little bit worn down, the letters, numbers, but all it is a 3.7 volt lithium ion battery. So yeah, pretty basic circuitry setup. Again, if you want me to explain how all the components are hooked up and what pins go to what pins, what ports go to what ports, let me know down in the comments and I'll do that. But now I'm going to go into describing the code for this program, or for this circuit. Again, pretty simple program. One more quick thing I forgot about that you guys might be interested in is for the wiring, I just use simple wiring. I mean, I just got this on Amazon. I think it's 12 gate or 26 AWG. So yeah, pretty thin wiring. And all I do for however long I need it, all I do is take it, cut it, however long I need it, and then I take a knife, grab one end, something like this, and fray, if I can do it, fray that piece off so you have the metal itself sticking out, and you can kind of twist it to make it easier to work with. And then you can solder this into any pins you want to, or connect it to anything however you want. So that's what I do. If you find something better, that works too. But I found this to be the easiest for because I can basically customize wire size instead of using set DuPont connectors. So yeah, now I will go into the program. So for the program, I have two different programs I use. One I call test for testing, and one I call final for this is what the final code I'm going to use for this circuit is, at least for now. So for the test, they're basically the same thing, but slight differences. So for the test, these are the libraries right here. I mean, they're just different libraries, and this is the just the sensor. And then, yeah, for the setup, for voice setup, again, I'm using the Arduino IDE. It's fairly basic. All you have is a setup, and that runs once when the program starts, and the loop, and that runs constantly. It loops throughout for however long the program's running. So you just begin the process. And this is just for the serial monitor, and this is printing on the serial monitor. So something interesting, when you work with the Arduino IDE, if you go to, I forgot what it's called, tools. If you go to tools and you go down here, you'll find the serial monitor, and this is pretty important for us. If you go over here, there's what's called baud, and what I've noticed is when I first tried it, I thought that, so when you are up here, when we put serial dot begin, and here's the baud rate, and I'm almost positive that this baud rate and this baud rate has to be the same for the program to work. But when I was doing that, it never worked. So what worked for me was 4800 down here and 9600 up here, or half down here and double up here. But then again, I don't know, you might just have to mess around with it. This is what worked for me. It might not work for you. So then right here, I just have like a little test print hello. So when the program first runs, it'll print hello. And this is initializing the sensor. So begin sensor. This is testing if everything's connected correctly. If it's not connected correctly and the sensor doesn't begin, it'll print fail, and then it'll wait. It'll just wait until the sensor is connected, and then afterwards it'll print hello again, just another test to see if everything's working. And then down here, void loop, this is loop itself, so you do float, so you turn this raw angle variable is going to be a float, and then this is how you read the sensor.read angle, times 360 to get it in degrees, or this is just to turn degrees. So yeah, this is what it'll look like for everyone who does it using this software. And then the minus 190.11 is simply to offset for the initial angle, so that when my brace is at 0, or when the KnexFlex is at 0, that the program reads 0. Otherwise, it would read 190.11. So I'm just subtracting that to set it to 0, and then it rotates and increases to whatever it is. And then yeah, serial.print angle. So this just prints angle, and then this prints the float detected up here. A float is basically just a decimal value, so like 4.6 or whatever. And then it delays for 10 milliseconds, I think. You can set it to 1, or you can set 10,000, however often you want it to read. I just have it set at 10. I don't know exactly what it's going to be when I'm done, but yeah, that's what I have it for now. So yeah, I'm just going to test run this program really quick. So if you connect the Arduino like I described earlier, then you'll see. So I already have the program loaded onto the Arduino, so it starts running right away. But say you haven't loaded anything onto the Arduino, or have something different, then you just go up here. Well, first press on here and find your Arduino that's connected. It'll pop up right away if you have it connected to your computer through the programmer. So just click on it and then press right here to upload. You'll see compiling, uploading, and once it's done uploading, it takes a second, then it'll be apparent. Yeah, so mine's the KnexFlex is at negative degrees right now. It opens up a little bit farther, but if I bend it, now it's basically at 0, and if I keep bending it, I disconnected it on accident. Okay, sorry about that, disconnected for a second, and some problems happen. But yeah, now if you see it, it'll track the angle as it bends. So yeah, that is how the program works for testing it. I mean, you might run into a couple problems if you disconnect it weird, or if it kind of disconnects for a second while you're running the program. It might mess everything up. You might have to just take out the programmer, put it back in, and re-upload the program. But it works most of the time. If you see any problems, if you see weird symbols, like little triangles and symbols and just weird looking stuff, it's probably your baud rate is off. That's exactly what it'll be. And if you have any failures, it's that your wiring's off. So now I'm gonna go to the final code. And basically the difference here is that instead of printing it all out, all it does is save it onto the SD card. So same libraries. This is the pin number for your CS pin for SPI communication. This is a setup. I'm not going to go too into depth in this. You can just copy if you want. And yeah, this is just opening the file, printing start of angle data, and then closing the file. And this is setting everything up, starting the sensor and the SD card reader. And down here of the loop, same thing, read the angle. All this is doing is opening the SD card file, writing the angle, closing it, waiting 1 millisecond or however many milliseconds you want. And then, yeah. So yeah, pretty simple code. So down here, it will not print anything into the serial monitor, of course, because when you're using it, you're not going to have it hooked up to the Arduino IDE. You just have it all downloaded onto the SD card reader. Later down the line, what I want to do is use a Bluetooth connected microcontroller that will just upload the values to your phone so you can see it live. So I've gone and hooked up or connected the SD card reader to my computer, and this is a folder. So same program, just ran it for a bit, and then it has it all saved now in a file called data.txt. And then, so yeah, this is the SD card, and it'll look something like this. So yeah, have all the data. Of course, it's recording a ton of data, but then again, they're only floats, so it's 8 bits, I think, or 16 bits per number. Barely anything. So yeah, but yeah, these are all the data. As you can see, is bending and stuff. This was before I accounted for, I forgot to do on this program, that's why, minus 119.11. But yeah, you see if I don't include this, then it reads numbers that are incorrect. You see if I don't do this, then it reads numbers that are incorrect. Oops. Like 194. So the angle itself is correct. It's just starting at the wrong value because I didn't account for the initial adjustment of the magnet. So yeah, that's everything. Thank you guys for listening, and let me know if you want any updates, any more information about these processes, about the code, about the program, about how to hook everything up. Thank you, and have a good one.